guys, welcome to our first lesson in Unit 5. We're going to talk about dilations, which is one of our 4 transformations. We covered reflections, rotations, and translations in our other unit, and now we're going to start with dilations. We put dilations in this unit because dilations create similar figures. Okay, and every time we have similar figures, we have properties of similar figures, which means that our corresponding, which means in the same position on a different figure, corresponding, in other words, in the same place, corresponding angles are congruent, and our corresponding sides are proportional, which is why we can use proportions to solve for missing side lengths in similar figures. The other thing about these similar figures, it's kind of the duh thing, is that they are the same shape and they're possibly different sizes. Every congruent figure is also a similar figure. But you can't have a rectangle similar to a triangle. They have to be the same basic shape. All right, so we can do dilations from the origin, and that's what we're going to focus on in this lesson, and then we'll have another lesson about dilations from a point. So if C is the center and it's at the origin, and that's going to be our center of dilation, point P is at x, y, those are just the coordinates, then P prime is going to be K times x and K times y, where K is your scale factor. Factors are numbers we multiply, such as 2 times 3 equals 6. 2 is a factor, 3 is a factor, and 6 is a product. If K is greater than 0 and less than 1, we're making a reduction. We're going to make our shape smaller. If K is greater than 1, then it makes it bigger. Notice K cannot be negative. It has to be greater than 1. The other thing about K, our scale factor, is that it's always the image over the original, also known as the pre-image. In this example, we're going to apply the transformation capital D means dilation to the polygon with these given vertices. A is at 1, 1, B at 3, 1, and C at 3, 2. You can see it right here. And K equals 3. That means all we're going to do is multiply every x by 3 and every y by 3. So 1 times 3 is 3, 1 times 3 is 3. For B, we have 3, so 3 times 3 is 9 for B prime. And then 1 times 3 is 3 for the y. 3 times 3 is 9, and 3 times 2 is 6. That's how we get our prime coordinates. I have plotted them both for you here. Here is our original. Here is our image. Now, I'm showing you something here. See these gray lines I've drawn in? When I draw a line connecting A to A prime, and I just keep extending it, and I draw a line that's connecting B and B prime, and I just extend it, and C prime, the place where all of these lines intersect, that is the center of dilation. Now here we knew it was supposed to be the origin, but we will be able to look at that later on and find it ourselves, whether it's the origin or anything else. So now we got to look at the ratio of the corresponding sides. So we're going to do image over pre-image. So here we're going to take the 6, which was our image, over the 2, which is our pre-image, the 3 over the 1. These are the corresponding sides. And I used Pythagorean theorem to get these numbers for my hypotenuse. And guess what? They all reduce to the same ratio of 3, or we can say 3 to 1. Which happens to match our scale factor. So let's take rectangle ABCD. It's dilated with the center at the origin, and now our scale factor is 1/2. So we know it should be a reduction. So basically, I'm going to multiply every single one of my x and y coordinates by 1/2. Multiplying by 1/2 is the same as dividing by 2. So 2 divided by 2 is 1. 2 divided by 2 is 1. 6 divided by 2 is 3. 2 divided by 2 is 1. 6 divided by 2 is 3. 4 divided by 2 is 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. Now I have my prime coordinates, and you can see indeed it was a reduction. Well, without the graph, I still follow the same procedure of multiplying with my scale factor. So now I've got coordinates of A, B, and C that are given, and it's dilated with a scale factor of 5/2, and the center of dilation is the origin. Is when it says is the center, it means the center of the XY coordinate plane, which is going to be 0, 0, the origin. Now, the thing of it is here, I want you to pay attention. 5/2 is greater than 1, so this is an enlargement. And then I'm going to multiply each one of these numbers by 5/2. So, for instance, example over here, 6/1 times 5/2. I always end up multiplying the top two numbers, and then I just divide by 2. So this would be 15. And if I go to 4, 6 times 4 is 24. 6 times 4 is 24. Oh, I'm not doing 4, so I'm 5. 5 times 4 is 20, divided by 2 is 10. Or I'm looking at a 4 at. 10 times 5 is 50, divided by 2 is 25. And so on and so forth. Here we're going to get 7.5 and 0. Okay, so now I want you to look at this and you try it. I've written the coordinates on the graph. We are going to dilate with the scale factor of 1/4, center of the origin. Remember, if we multiply by 1/2, it's the same as dividing by 2. And if you are multiplying by 1/4, that equals dividing by 4. So I'm going to just divide 4, every coordinate by 4. So you should have 2, 1, 3, -1, and -1, 0. 2, 1, that should be P prime. 3, -1, that's going to be your Q prime. And R is at -1, 0. It is indeed a reduction. This is 1/4 the size of this. Now, how are the distances to the origin from each image point related to the distances from the origin to each corresponding pre-image point? In other words, the distance from P to the origin and from P prime to the origin. How do these distances compare from R to the origin and from R prime to the origin? Okay, I have my R graphed at the wrong spot, my R prime. Let's fix that quickly. That's supposed to be at -1. So that's going to be 1, and that's going to be 4. Down here, I've already calculated the distances using my distance formula and my coordinates. So from P to the origin is root 80, and from P prime to the origin is root 5. When I do my image, these are my images in blue, over my pre-images, the green, it reduces to 1/4. Same thing for point Q and for point R and R prime. Notice, this is my scale factor. They all equal the scale factor. So our scale factor is even in play there. All right, now we're looking at this rectangle A, B, C, D, and A prime, B prime, C prime, D prime. And the center of dilation is point P. So you can see, you can draw, it's hard to do with this, you could draw a line with the pre-image and image points, and they all intersect at point P. When you compare the side lengths, AB equals 3. A prime, B prime is 9. BC is 2. This one is 6. CD is 3. 9 and 6. If you set them all up in ratios, they all reduce to the same number, or same ratio, which is 3/1. So all of the corresponding sides are proportional, and our scale factor is that proportion. or is that ratio. Scale factor is that ratio. Another example to look at. We want to determine whether the polygons with the given vertices are similar. So you can see where I plotted the A, B, C, D, and where I plotted H, I, J, K. I could count these side lengths. And so I set them up. I have to either go from the little over the big, little over big, little over big, little over big, which all reduce to the same ratio of 1/3, or I have to go from big to little, big to little, big to little, big to little, which all reduce to 3/1, which is the same ratio. Just depends on which one is the image. But again, they're all in the same ratio, so yes, the figures are similar because all of the corresponding sides are proportional. In this example, they've already graphed them for me. I use my Pythagorean theorem to get my hypotenuse, and then I have to ask myself, does 2/4 equal 1/2 equal √5/√20? They all reduce to 1/2, so yes, all corresponding sides are proportional, and triangle ABC is similar to DEF. The ordering of the letters here matters. It has to follow mapping. In other words, the congruent and corresponding angles have to be in the same position. If I'm going to have something such as this, where I have a pentagon dilated using a scale factor of 1/6, that means to multiply. Well, if the original is 24 inches, I multiply by its scale factor. I know that C prime D prime is 4 inches. And here in my triangles, if they're dilated by a scale factor of 2/3, dilated by a scale factor. That means I have similar triangles, and they are in this order. I know that C lines up with Z. They're asking me if A is 50, B is 100. Triangle sum theorem tells me that C is 30. I know that C and Z are corresponding angles in similar figures, so they're congruent. So Z equals 30 degrees. Now here's our last little example we're going to look at. And we're talking about these overlapping triangles. So I've kind of taken them off of here. They tell you that point P is at -15, 0, and M is at -10, 0. Well, I know that leaves 5 spaces here and 10 spaces here, based on the differences there. So if I go all the way from here to here, that's where I get the 15. And then I have my 10. I need to know what this length is so that I can get my coordinates of N. So I know that the whole thing here, I drop down to 30. I set up my proportion here. Find out that X equals 20. So I know that this part is 20, making my coordinates of N be 0, -20. Now it asks for the scale factor, and again, I'm not being told whether I'm going from the smaller triangle to the bigger triangle or from the bigger triangle to the smaller triangle. So if I'm going from the large one to the big is my image, so those will go on top, those dimensions, and then my pre-image will go on bottom, and it would be an enlargement going from small to big, so K should be greater than 1. If I'm going from the big to the small, then I'm going to have my small as my image. Those are going to be my numerators and my scale factor, and the big ones will be the denominator. And then as expected, since I'm going to make something smaller, my scale factor is going to be less than 1. Okay, so those are the basics for dilations about the origin. Feel free to go back through, pause, work some more examples a little more slowly, see if you have any questions. If you do, hit me up on It's Learning or ask me in class. And I hope you're having a good day, and I will see you in our next lesson.